Hey everybody, this is the test review, test 1 review, and we are on number 6. Okay, so for number 6, mine says the limit as x approaches -3, and then there's a fraction of x squared minus 4 over 3 minus x on the bottom. Okay, so when we have equations, not pictures, but equations, the first thing that you do is you try and plug in this number that x approaches into the denominator. That's the bottom. And if you get a 0 in the bottom, then we have to do something else. But let's see what happens. So I'm going to take this -3 and put it where all the x's are. So instead of this x squared and this little minus x on the bottom, I'm going to put parentheses -3. So parentheses -3, close parentheses squared minus 4, all over 3 minus parentheses -3. And then if you don't put parentheses, you might get it wrong because the calculator doesn't know that you're squaring -3. So if you were to put just -3 squared like this, it's going to give you the wrong number. That spits out -9. But we want -3 in parentheses squared, which is parentheses -3, close parentheses squared. Whoops, no plus sign. Okay, so now that I have parentheses, I get +9. So make sure you use the parentheses. Otherwise, the calculator doesn't know what's going on. So on the top, we get 9 minus 4. And on the bottom, since there is no squared, we just say, hey, when you see a double negative, it becomes a +. So on the bottom, that double negative of the negative that x approached and the negative that was already in the bottom of the fraction becomes a +. So that makes 6. So the top is 5 and the bottom is 6, and hot dog, that's your answer, 5/6. If we would have gotten a 0 in the bottom instead of that 6, then we would have to do something else. Okay, let's try number 7. Number 7 is one of these piecewise functions. Yeah, okay. And it looks like for part A, we want x approaches 0 from the plus sign. So that means right. Part B says x approaches 0 from the negative. That means left of 0. Part C says x approaches just 0. That's where you consider both of your previous 2 answers. And then the last one, part D, with the f of 0, that means the closed hole from the graph or the solid curve. Or for this problem, we don't have a curve or a hole to look at. We just have equations. So for this last part, besides closed hole and solid curve, it's also an alligator with an equal to. So for part A, we look at the right, part B, we look at the left, part C, we look at both, and part D, we look for, since we don't have a picture, we just look for the alligator with the equal to. Okay, so let's look at this piecewise equation up here. It says f of x, and there's 2 different equations. And then what determines which equation we look at is this next part, for x less than or equal to 0. Well, things that are less than or equal to 0 are on the left of 0. Whereas if we look at this next for statement that says 4x bigger than 0, those are numbers bigger than 0, as in to the right. Okay, so just like we did on number 6, where we plugged in what x was approaching into the equation, we're going to do the same thing here. We're going to plug it into our equation. We just have to figure out which equation to use. So for part A, it says as x approaches 0 from the plus, as in the right. So that means we're going to use this second equation, because the second equation says x is bigger than 0, and those are the numbers to the right of 0. So our equation is 6 minus x that we're using, and we're going to plug in whatever x approaches underneath our limit. So let's look. It says LIM, x approaches 0. So I'm going to put a 0 in for this x. So negative 6 minus 0 is negative 6. Hot dog. Yeah. Okay. Now let's look at part B. Part B is asking for the left of 0 because it says x approaches 0 with the little negative in the air. So we go up to our piecewise, and earlier we said that the left meant x less than 0. So that's negative 1, negative 2, negative 3. And that's everything to the left of 0. So that means we're going to use this top equation for part B. So for part B, we're going to use the top equation of 6 plus x. Then we're going to plug in our number that x approaches 0. So 6 plus 0. And if you're wondering, wait a minute, what does that little negative in the air mean? Remember that negative in the air means left, and left means we use this first equation. So that little negative and that little plusative in the air just tell us whether we're looking at left or right and which piece of the equation we're going to look at. Anyway, so for part B, 6 plus 0 is 6. And I think I wrote down part A wrong. It was supposed to be negative 6 minus, no it wasn't. It was supposed to be regular 6 minus x. Moron. Such a moron. Okay, so this is supposed to be regular 6 minus x. Part A, as in a positive 6 minus x. Positive 6 minus 0, which is positive 6. My bad. You guys probably already caught that. I'm not redoing this video. Okay, so anyway. Part A was positive 6. Part B was positive 6. Part C, we consider the previous two answers. So since the previous two answers were both 6, as x approaches just regular 0, the answer is 6 also. And it's only 6 because the last two from the left and the right were both the same. So since the left and the right were both 6, as x approaches just 0, the answer is 6. If these last two were different, then I would say part C does not exist. So if part A I got negative 6 like I had in the beginning, and part B I had regular 6, then part C would be does not exist. So the only way you have an answer for part C is if part A and B are matching. Okay, part D says f of 0. And usually when we have a picture, f of 0 means where the closed hole is. Or when you see that f, it means the closed hole or the solid curve. But we don't have a picture. So the only way we can figure out what the closed hole or the solid curve is from our equation is to look for the alligators with the equal to. So let's go back up to our equations, and there's only two pieces, two different equations, one for x less than equal, one for x bigger than. Well, for the f of a number, you either look at the closed hole, the solid curve, or where the alligator has that little equal to. So see this first alligator as the equal to? So I'm going to plug in my number to 6 plus x. So in my equation is 6 plus x. And then I'm going to plug in that number in the parentheses, which is also 0. So 6 plus x is 6 plus 0, and that's just 6. So the last answer is 6 also. And we got that by picking out the piece of the equation that had the little equal to underneath it. Okay, let's look at number 8. Number 8 is a big boy, so I think I'm just gonna work it out on some notebook paper. Okay, number 8 says f of x is negative 2x minus 7. And then it tells us to use this formula. Woo, okay. So they gave us this f of x equals negative 2x minus 7, and they gave us the formula. Hallelujah. Okay, so first we're going to start by finding f of 6 plus h. Yeah, okay. So to find f of 6 plus h, I'm going to take this f of x, and I'm going to plug in a 6 plus h where all the x's are. So instead of f of x, we now have f parentheses 6 plus h equals, and no more negative 2x minus 7. Now we have negative 2 parentheses 6 plus h minus 7. So we're supposed to use this huge formula with the limit in it, but we can't just start plugging stuff into that formula. We have to find each piece one by one. So first we're finding this f of 6 plus h. So let's distribute. And negative 2 times 6 is negative 12. Negative 2 times h is minus 2h. And then there's a big fat minus 7 that I'm just going to bring down. Okay, now let me combine like terms. There's no other h, so let me just write negative 2h. But then negative 12 minus 7 is negative 19. And what was this equal to? This was equal to f of 6 plus h. Okay, so we found the top left of this formula. This f of 6 plus h is going to be replaced with negative 2h minus 19. Okay, now what we need to find is the top right of this formula, this f of 6. And we're going to do it the same way that we just found f of 6 plus h, only it's less work. So now we're going to find f of 6. And we're going to take that 6 and we're going to plug it into this equation of negative 2x minus 7. So we're going to have negative 2 times 6 and then minus 7. So all I did was take this 6 and plug it into this f of x equation. F of x equals negative 2x minus 7. Okay, so this gives me negative 12 minus 7, and that makes negative 19. And that's f of 6. So in my little formula, instead of f of 6, I'm just going to write minus 19. All right. Okay, now that we have those two found, we can use our formula. So our formula says limit h approaches 0. So let's write that down. Limit h approaches 0. Okay, this f of 6 plus h is f of 6 plus h. Negative 2h minus 19. Then the formula says a fat minus. Then my f of 6, which was green. So my f of 6 was over here. F of 6, negative 19. So I'm going to put minus 19. Whoa, where did these two negatives came from? The first negative came from the formula. The second negative came from when f of 6 was actual negative 19. So I had to put two negatives, one for the negative 19 and one for the actual formula has a minus in between, all over h. Okay, now we're going to try and cancel some stuff. I think the 19s, let's see, this double negative makes a plusative. And then after that, the 19s cancel because negative 19 plus 19 goes away. So all we have left is limit as h approaches 0 of negative 2h over h. Okay, the next thing that we're going to do is we can cancel some h's. Wow. Just a pair at a time. They're both the same. So we just have negative 2. Woohoo! And then if I still had an h left, I'd plug in this 0 into the h that I had left. But I don't have any h's left. So if I still had, let's say I still had negative 2 plus 3h or something. I don't know. Just pretend. Let's say I still had an h. Then my very last step would be to plug in this 0 into the letter h. And I'd still just get negative 2. But the point is I would be able to plug in a 0 into an h because I had it left over. But on our problem, we didn't have an h left over, so I could not plug in 0 for h. So my final answer is just negative 2. Yeah, woohoo! Okay, let's go back to that test review. I think we can go back to the worksheet. Okay, on that test review, number 9, it says refer to the graph. Okay, so it says limit as x approaches infinity. So that means as I look more and more to the right of my equation, what's the y value going to become? So here's my graph, and let's find when x is infinity, because that's what we're supposed to find in the limit of. So where is x-axis? Oh, it's the side to side. Okay, where's infinity? It's somewhere out here, like way to the right. So it's asking, as we approach this x infinity, so as I come down from this curve and go all the way to the right, the question is, what is your y value going to be? Well, you can't really tell, but it looks like this curve kind of levels off and it's never going to go down or up. So technically, that means there's an asymptote right there. And since there's an asymptote, that's like saying it's the boundary, it's the limit. We cannot go lower than that asymptote. So as x approaches infinity, your y value, it goes down, but then it looks like it levels off at whatever the y value is for this asymptote. If we look closer, the y value for this asymptote is negative 4. So that means that this side-to-side asymptote levels off at the y value of negative 4. So that's my limit. Yeah. So the limit as x approaches infinity is negative 4, because as I follow this curve to the right side of the graph all the way at infinity, as I follow the curve levels off at that asymptote at negative 4. Okay, let's keep looking. No, video is too long.